All right, now that we're pros at being able to label our triangles, let's jump into how do we use this. All right, so the first thing I want you to do is I want you to write down your trig functions. So the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite and adjacent. And then I take a moment to stop and make sure that I got it correct. Okay. By the way, that is not, those three formulas is not something that you'll have to memorize. If you have to take the SOL, those are three things that they actually give you on the formula sheet. And then as always in here, you can use your notes. So there's not a real reason that you have to remember those functions, but you do have to know how to use them. Okay. So here's my given angle, 37 degrees. And then I'm just going to take and I want to label all three of my sides like I've practiced doing. So hypotenuse. And then the side that goes between the angle and the right angle is the adjacent. And then I've got the opposite. Okay. So I've got my three sides labeled. And then I want to look and say, okay, I have an X over here with the opposite, and I have a 14 with the hypotenuse. So I have 37 degrees, I have the hypotenuse, and I have the opposite. So let me write this down. So I don't want to write it in the highlighter. So I know that theta, the angle, is 37 degrees. I know the hypotenuse is 14. I know the opposite is x. So I'm going to look at these functions. I have the hypotenuse and the opposite. So in my functions, what function uses the hypotenuse and the opposite? Right, here's sine. Opposite hypotenuse. Okay? So here's what I do. I say that the sine of 37 degrees, because that's what theta is, equals the opposite, which is x, over 14. Oh my gosh, how am I supposed to solve that, Miss Bearden? Well, let's see. Yesterday, you should have realized that when you type sine of 37 degrees into your calculator, all it is a decimal. It's just a number. And remember, we can put any number over 1. Doesn't change anything. And whoa, wait a minute. This looks like I'm getting ready to cross multiply. Oh my goodness, how long, like is that all I'm going to do for the rest of my life in here is cross multiply? Yes, actually it is. I told you cross multiplying would be really important from this moment on. So when I cross multiply, I'm saying 1x equals, and I'm going to cross multiply here. Put the number in front of the function. That will be really important because that's the way that you're going to have to type that into the calculator. So 1x, I can just erase that 1 and I can just type an x. So x equals my number 14 times, I'm going to use parentheses, my trig function, sine 37. Now, I didn't check to make sure, but it is in degrees mode. Sometimes it'll be okay for you, sometimes it won't. Now, notice I had to put in a second parenthesis there. And what do I get? X is 8.4. So it is very common when you're working with trig functions that you get decimals as your answer. All right? It's very common. Next example, we're going to do the same steps. Sine theta equals opposite hypotenuse. I don't want to write the whole thing out. Cosine theta equals and tangent. All right. So sine theta, cosine and tangent. Yep, I got them right. Now I'm looking at 40 degrees. Now I want to label everything because in relation to that 40 degrees. So this is the hypotenuse. The side between the two angles is the adjacent. And then that means this is the opposite. All right, so what do I have? I have theta is 40 degrees. I have the adjacent, which is 13. I have hypotenuse, which is x. If I thought that I had the opposite side, here's what would happen. I have opposite, and the opposite is, I don't have anything to put there for the opposite. So that's how I know that I don't have anything for the opposite side. I don't have a value that I can substitute in for the opposite side. So I'm looking for adjacent and hypotenuse. Sine is opposite in hypotenuse. Cosine, adjacent hypotenuse. Yep. So it's the cosine. All right. So cosine of theta. Theta is 40. The adjacent is 13. The hypotenuse is x. All right. Over a 1, cross multiply. 13 equals x cosine 40. So now, typing it into Desmos, what do I get? 13 equals x function cosine 40. Now, this is another way that you can type this in and you don't have to use that extra set of parentheses. And it works just fine. Scroll down and I get 16.97. So if I had to round this one to the nearest tenth, so x equals 16.97. And if I round this to the tenth, 7 would round that to a 10, and it would round that to 17.0. Okay? Another example, same thing. Sine theta equals all right, I got my 3 functions written out. Sine of theta equals opposite hypotenuse. Cosine of theta equals adjacent hypotenuse. Tangent of theta equals opposite over adjacent. Now, 21 is my angle. So here's my hypotenuse. 25 is between the right angle and 21 degrees. So this would be my adjacent side. And then that means that the x would be my opposite side. All right, what do I have? So theta equals 21. Opposite equals x. And adjacent equals 25. I don't have anything that I can replace the hypotenuse with, so the hypotenuse is not something I'm going to use in this problem. That means that I'm going to be using the tangent function. It's the function that uses the opposite and the adjacent. So, tangent of theta is 21. The opposite is x. The adjacent is 25. Over 1, cross multiply. X equals 25 times tangent 21. All right, type that in. X equals 25 tangent 21. Now, because the x comes first, it'll just spit the answer out. I don't actually have to go up here and click on my dot. Because the x is by itself and comes first, it'll actually just tell me what x is. So x is 9.6. There we go. One more slide. So I got to find QR. So it wants me to find QR. So I look, and here's QR. So that's what I'm finding. That's where I'm going to put my X. And that way I know what I'm looking for. Now I'm going to go back and label everything. So this one looks tricky because when you look at that X, it looks like it's slanted and like you would want to call it the hypotenuse. But actually, here is the hypotenuse. Remember, the hypotenuse is across from the right triangle. My adjacent side is between the right angle and the angle that they give me, the theta. And that means that that X side is actually going to be the opposite side. So theta is 63. The opposite is X. And the hypotenuse is 12.9. So what were those three functions again? Sine theta, cosine theta, tangent theta. And if your parents are my age, 40-ish, and they went to high school here at Floyd, and they took trig while they were in high school at Floyd, or maybe some other little town, they were taught a little acronym in order to remember the sine, cosine, and tangent functions. You should have that conversation with your parents and see if you can jog their memory about the acronym to remember sine, cosine, and tangent. Be a good conversation. Oh, right. I'm looking for the opposite and the hypotenuse. Opposite and hypotenuse. Here we are. That's my sine function. So sine 63 degrees equals the opposite, which is x, over the hypotenuse, which is 12.9. Put it over 1, cross multiply. X equals 12.9 sine 63. Again, I can't tell you how important it is, or I can't stress to you how important it is that you have that number in front of your sine. It will completely change your answer, and you'll get the wrong answer if you don't put that number in front by itself. And we're getting 11.5. X is 11.5. Last problem. All right, here's 39 degrees. I'm trying to find FD. So, FD is where I'm going to put an X. That's what I'm looking for. Looks like X is the hypotenuse. And it looks like 20 is between F and E. So this would be the adjacent side. This time I'm not going to, and then DE would be the opposite side. So I don't have anything for the opposite side, so I'm just going to stop writing stuff when I don't have a number there. Sometimes that gets more confusing when I've written something, but I don't actually have a value there. So what do I have? I have that theta is 39. I have that the hypotenuse is X. And I have that the adjacent is 20. I have the hypotenuse and the adjacent. Hypotenuse and the adjacent. Hypotenuse and the adjacent. That would be cosine. So, cosine 39 degrees equals the adjacent and the hypotenuse. Cross multiply. And now I'm going to go to my friend here, see what my friend tells me is the answer. 20 equals X cosine 39. Adjust my view a little bit. X is 25.73, so X is 25.7. That's it.